In this video, we want to take a look at complex ions and the oxidation state of the central atom. So we have complex ions. So what are complex ions? These are simply ions that are made up of two or more elements. So we say they're made up of two or more elements. Then we'll call it complex ion. Okay. So some example of complex ions may be sulfate, anion, or chlorate, ClO3 minus, or even more complex ones such as copper, H2O4. These are all examples of complex ions. Okay. Now there are things that we have to know. Any complex ion will consist of two parts. Okay, every complex ion consists of two parts, and these two parts are the cation. It has a central atom. Sorry, it has a central atom, which is the cation. It also has the anion, or what is known as ligand. Okay, so for example, when we take sulfate over here, sulfur is the central atom. So say that sulfur is the central atom, and then it has the ligand, which is the oxygen. Now the same thing we have here. Copper here is the central atom, and then water is the ligand. Okay, so that's how to make up a complex ion. Now what you have to know is that the central atom has an empty orbital which allows the ligand to donate the electrons into it. So usually the ligands are electron rich and they donate this electron into the empty orbitals of the central atom. Now it is important to be able to calculate the oxidation state of these central atoms. It is a crucial part of naming an inorganic complex. Okay, so another thing to take note of is that we have we have two types of ligands. We have two types of ligand. These two types are the charged ligands, and then we have the neutral. We have the neutral ligand. Okay, so usually you'll be given a complex ion that may contain one or maybe two or more different types of ligands in there. Now you have to be able to determine which ones are neutral and which one has a charge, because that is what you use in naming them. Okay, so let's look at some examples of charged ligands and neutral ligands. Now, fluorine, when it is charged and it is a ligand, is called fluoro. Chlorine is known as chloro. Bromide is known as bromo. And then we also have others. Oxygen minor oxide is known as oxo. Now, if it is a peroxide, that is going to be peroxo. A hydride is known as hydrido. What about sulfate? It's known as sulfato. So these are some examples of charged ligands. Okay, all these guys have a charge on it. Like fluoride here has a charge of -1, chloride -1, bromide -1, oxo has a charge of -2, and so on. Now we have the neutral ligands. The neutral ligands do not have any charge, they are neutral. Now, so the neutral ones that we have water, which is referred to as aqua. Ammonia is also neutral. As a ligand, it is called amine. Then we also have carbonyl, and we also have nitrosyl. So these are some neutral ligands, okay? So you would have to use these to find the oxidation state of the central atom. And so how do you do that? Let's look at some examples. All right, so let's say you've been asked to calculate the oxidation state of copper in this complex. How do you find the oxidation state of copper? So this is copper, and we'll have to add the net charge of water. But we know that water is neutral, so we have 4, and the net charge is 0, which is equal to the charge on the complex, which is what? 2, okay, plus 2. So this is copper. Copper has an oxidation state of plus 2, okay? What about what about FeCN4 NH3 2 with a net charge of minus 2, and you've been asked to determine the oxidation state of the central atom. The central atom here is ion, okay? In other words, it is a cation over there. So you've been asked to determine the oxidation state of ion. What do? We'll add all the charges. Ion here plus Cn minus. Cn minus is known as what? Cyano. Cyano, okay? And it has a charge of minus 1. And so we'll have 4 times minus 1 plus 2. Ammonia here is neutral, so it's going to be 0. All equals minus 2, okay? The charge on the complex is at minus 2. And so we'll have Fe plus minus 4 plus 2 times 0, which will give you 0, equals minus 2. And so we'll say that we have Fe, if we take the minus 4 to the other side, it becomes minus 2 plus 4. So ion has an oxidation state of plus 2. Okay? Ion has an oxidation state of plus 2. Alright. What about this one? You can pause the video and try this one. Copper H2O3 NH3 with a net charge of plus 3. What will be the oxidation state of copper? Alright, to work this out, we have copper plus the charge of water. Water is neutral, and so it's going to be 0. Okay. Ammonia likewise is neutral, so 0 equal to plus 3. So copper plus 3 times 0, 0. 3 times 0, 0 equals plus 3. So we say that copper has an oxidation state of plus 3. So this is how to work out the oxidation states of central atoms in complexes like this, and you will need this in naming inorganic complexes. Okay, remember to like this video and subscribe, and watch out for the next tutorial on how to name these complexes. Thank you.